Hello and welcome. In this video we're going to take a look at how we can add data loaders to a Hot Chocolate GraphQL API. Data loaders allow us to batch multiple requests to, for example, a database into a single request. So we might have potentially a dozen queries that all query the database to get a particular entity, but using a data loader we can convert those individual queries into a single query, which helps to improve the performance of our API and also helps to reduce load on the database. And it's important to also note that whilst we're going to cover the scenario where we have queries in a database in this sample, you can also use data loaders to fetch data from other sources, for example other APIs, and not only just for databases. But for the purposes of this sample, we're going to use a database. So you'll notice over here on the left-hand side, I have a basic GraphQL API. We have an application DB context class with an authors table and a books table. Our author entity contains an ID and a name, and our book entity contains an ID, a title, and an author ID. The foreign key there between the book and author tables. That essentially means that we have a one-to-many relationship between author and books. In our app settings.development.json, we have our localhost connection string. I have a Postgres database running locally, but feel free to use any other database of your choice for this sample. We then have a query class, which contains an authors query and a books query, which simply returns authors and books from the database. We then have our author type, which contains an additional field here called books, and the books field has a resolver to fetch the list of books that an author has authored. You can see there on line 12 the query getting all books where the author ID matches the author in this particular resolver, not forgetting that the resolver will run once for each author fetched from the database. And we have something similar inside our book type. You can see that we're replacing the author ID field with an author field, and that is using a resolver to fetch the author matching the author ID, so that returns all of the properties of the author, for example their name, rather than just the author ID. And then last but not least, we are wiring it all up together in our startup, adding in our application DB context, and then also registering our DB context with the GraphQL server, adding our query type, and also adding in our author type and book type. You'll notice then towards the bottom of the startup, just above app.run, if we are running in the development environment, then we are seeding the database with a number of authors and books for the purposes of this sample. So if we take another look in our book type resolver, you'll notice that this is essentially running a query in the authors table to find the author that matches the author ID of the current book. However, if we return 9 books from the database, then this resolver is going to run 9 times. And that means that we're going to execute 9 individual queries to fetch author by ID. Now this is where we can use data loaders to streamline and make that process more performant, because using a data loader we can batch those 9 individual SQL queries into one SQL query and then deal with the results in the data loader. So what we're going to do is rewrite this resolver slightly to use a data loader to make that more efficient and reduce load on the database. So what we are going to do first of all is just to show you the 9 individual queries. I'm going to run the API like so. And then if I come over here into Banana Cake Pop, I have a query ready to go which gets books and it gets the title of the book and also the name of the author. Just reload that schema, and if I now run that operation, you can see that we get our 9 books back from the database. And if we take a look at the output in our API, you can see that we have 9 individual SQL queries, each selecting ID and name from authors, where the ID matches the author ID of the current book being executed in that resolver's context. So what we're going to do is stop that, and then we will now start working on our resolver. So what we're going to do is we're going to add a new class in our API, and we're going to call this author data loader. And the author data loader is going to extend the batch data loader, and this takes two generic type parameters. The first type parameter is the type of the key or the identifier for our entity. In this case, this is the author entity, and that uses a GUID as its primary key type, as the identifier type. And the second generic type parameter is the actual entity type itself, which in this case is author. So we have GUID, which is the ID of the author, and then we have the author type itself as the second type parameter. We can then implement those missing members, which creates us a constructor, and it also implements this load batch async method. And the load batch async method is where the logic takes place to actually load the entities from, in our example, the database. But this could be where you add logic to fetch authors from another HTTP request, for example. So what we're going to do is we're going to inject in our application DB context, like so. Add that into the constructor. And what we're going to do inside our load batch async method is query the database to get authors where they match the keys that are passed in to this method. Now you'll notice that it's passing in a list of keys rather than a single key, and that's what enables us to do the batching in the database, because rather than filtering on a single key, we instead can filter on multiple keys and reduce the number of queries from 9 individual queries to a single query with 9 IDs, or keys in this case. So what we can do is we can say var authors equals await context.authors.where, and inside our callback we'll have a lambda there, and we can say keys.contains author.id. And then we can say .toList async, and then we can pass in the cancellation token, like so. And what that's basically doing is it's saying go off and get me all of the authors from the authors table in the database, where the author ID is present in the list of keys that are passed to the load batch async method. And you'll notice the return type is a dictionary with a key of GUID and a value of author, and that's essentially converting that result into a mapping where we map the identifier of the author with the author itself. And that's what the batch data loader essentially uses to do a lookup using the ID of the author to then get the author entity itself. So what we're going to do is we'll say return authors dot to dictionary, and then the key selector will be an author lambda, and we will simply return author.id as the key selector. So that means that we're going to return a dictionary with the author ID as the key, and then the author itself as the value. In other words, the author entity from the database as the value of the dictionary, keyed using the author's identifier. So what we will do now is add that author data loader into our startup. So where we have builder.services.add GraphQL server, we're going to add data loader, and then we're going to say of type author data loader, like so. And then last but not least, we will come into our book type, and we can now update the logic inside our resolver to use the data loader. So what we will do is we'll say var key equals context dot parent of type book dot author ID, like so. We can keep the cancellation token because we will use that in our call to the data loader. However, on line 14, where we return await context.service, we can instead say return await context.dataloader, and this is going to be of type author data loader. And then what we're going to do is say load async, passing in the key and the cancellation token. And that's then going to bubble down through the batch data loader, and it's going to call our load batch async method, which is then going to go and fetch all of the authors which match the author IDs that are passed into that method in a single query rather than, in this case, 9 individual queries. And you might be wondering, well, how does that work? Because this is calling load async with a single key, a single author ID. And that's because GraphQL, Hot Chocolate internally, batches up those queries inside the data loader. So it waits for all of the resolvers to run, and then it will batch those queries all together into a single query, call that load batch async method once, execute that query, and then it will use the lookup in the dictionary to return the appropriate author to each of our individual resolver contexts. So that's how essentially internally it translates this load async with a single key, batches all of those up together, and then calls that load batch async method that we implemented in the author data loader to execute all of those, what would be individual queries, as a single query. And you'll notice that we also still have our call to serial because we were using the DB context within the resolver previously. What we can do is we can now remove that call to serial because these resolvers can now be executed in parallel, because as we just explained, each of those queries is being batched up into a single query. So each of the resolvers can run in parallel. All of those calls to load async in the data loader can run in parallel, and then we're only running a single query within the author data loader load batch async, and that single query then will run at the end of each of the resolvers. So what we can do now is take a look at this in action by building and running the API once again. Give it a few moments there to spin up, and if we come back here into Banana Cake Pop, just give the schema a reload, and if we now rerun this operation, we get the exact same results as before, our 9 books, each with their author. However, you'll notice that the query now is slightly different. You can see that we run a single query to select ID, author ID and title from books, as we were doing previously, but then notice this second query, selecting ID and name from authors where the ID is in and then a list of the author IDs. So essentially that has combined the 9 individual queries on the authors table into one single query where we're checking to see if the author ID is in the list of 9 author IDs. And that's resolved essentially from the author ID here in the context.parent of type book.author ID, collecting all of those 9 author IDs together from each of the resolvers, and then once it has all of those author IDs, it's then running a single query in the database at the end of that to fetch all of the authors which have an ID that's one of those 9 author IDs. And then internally, the batch data loader is then using that dictionary lookup to match each of those IDs with the specific author, and it's then returning that single author from our resolver as the author field. So that's shown you how you can use the batch data loader, which is useful when you have a one-to-one relationship, or in this case, you're looking up a particular entity by an identifier, a single entity by identifier in this case, looking up a single author by the author ID. However, if we turn our attention now to our author type, you'll notice that we're not returning a single type, we're returning a list of types. In this case, we're returning the list of books that that particular author has authored. So for that, we can use a slightly different data loader. We can use the grouped data loader. And that's useful for one-to-many relationships, or where you're looking up multiple values by a single key. In this case, we're looking up multiple books by a single author ID. That's the one-to-many relationship between author and books that we showed earlier in our database context class. So what we'll do is we will terminate that, and we will now create a grouped data loader for our author type resolver. So what we're going to do is we will right click API, we're going to add a new class, and we're going to call this author books data loader. Add it into version control, and this is going to extend the grouped data loader class, and very similarly to before, this takes in two generic types. The first generic type parameter is going to be the key type, the identifier type, and once again that is a GUID because each of our authors and books are identified using GUIDs as the identifier. And the type that this is going to return is a book, because this is going to be returning a list of books for each author ID. So we have the GUID there being the type of the author ID, and then book being the type that is being returned in the lookup, a list of books. That's slightly different to the author data loader, which had the GUID as the author ID, the same as this one, but it was returning a single author type rather than a list of book types. So what we can do is we can implement the missing members, and we have a load grouped batch async method instead of just load batch async method. And then we have our default constructor with the parameters being injected in. And much the same as before, inside that load grouped batch async, you can call a database, or you could also call another API using an HTTP request. In this sample, we will use the database, but as I say, you can swap that out for any other data source, for example, another API using HTTP requests. So what we'll do is we will say private application DB context with the getter, and we would initialize that property from the constructor using dependency injection. And what we're going to do in here is we're going to fetch the books that match the author IDs. Now the author IDs are the keys that are passed into the method. So what we can do is we can say var books equals await context.books.where, and then we can say book with our lambda syntax, and then we can say keys.contains, and then book.author ID. Then we can do a toList async, and we can pass in the cancellation token like so. And what that's basically doing is it's saying go into the books table in the database and fetch me all of the books where the book has a matching author ID that's in one of the values of the keys that are passed into this method. So the keys that are passed in are going to be a list of author IDs, and then that query is basically going to get books from the database where the author ID of the book is present in that list of author IDs that's passed into the load grouped batch async method. So what we can then do is say return books.toLookup, and this is going to be keyed on book.author ID. So what that's saying is essentially convert the list there into a lookup using the author ID of the book as the key, and then the grouping of that will then be the books that that author has authored. So slightly different return type to our batch data loader, because that returned a dictionary, whereas the grouped data loader returns a lookup. Again, similarly though to before, the key selector in that lookup is the author ID, and then the grouped list of values in that is, in this case, the list of books that that particular author has authored. So what we can do is add that into the startup logic. So where we have our call to add GraphQL server, we can say add data loader, and we can say author books data loader. And I should note at this point, our previous batch data loader was just called author data loader, whereas this grouped one is called author books data loader. Now that's because if we take a look at the author data loader, that is returning a list of authors and it's keying those on the author ID. So this could be used in any scenario where we want to batch requests to get authors by the author ID. In our book type, we're using the author ID property on the book entity, but if you had another table with a relationship with authors, then you could use the author ID on that other table. So we don't particularly need to call this class book author data loader. Just because we're using it with the book type, you could use it with any other type that has an author ID foreign key property within it. So that's why we keep it as just author data loader, and then that enables us to reuse it with not only the book type, but potentially any other type that you might have in your database schema. However, our author books data loader is slightly different because this is specifically querying for books using the author ID. So that's why we specified it as author books data loader, because this can only be used in the scenario where we are querying for books using the author ID of that book. So what we'll do now that we've added it into Startup is we'll come down here into our author type, and we can rework our books resolver ever so slightly. So what we're going to do is we're going to say a var key equals context.parent, and this is going to be of type author, like so. And then we're going to say .id. So this is the key type that we're going to pass into the grouped data loader. And then what we're going to do underneath that is we're going to say var cancellation token equals context.request aborted, and that gets us our cancellation token. And then where we currently have the call to context.service, we're going to replace that with context.dataloader, and we're going to say of type author data loader, of type author books data loader. And then we can say load async, and we can pass in our key and cancellation token. And then what we can do at the start of that is make it return await, and then make the resolver asynchronous. Same as we did before, we can also remove the call to serial, because we're no longer using the application DB context directly in the resolver. We're much the same as our previous resolver, batching all of those SQL queries up together, and then we are executing one query at the end of all of the resolvers, executing that one query in the data loader using the DB context that's injected into the data loader itself. And then essentially this is taking the key, which is the author ID, and it's going to return us the list of books that that particular author has authored. So what we can do now is we can build and run the API, and we can see that author data loader in action. So if we pop back into our browser, and we can modify the query in banana cake pop, and what we're going to do is we're going to return authors, we're going to return the name of the author, and we're also going to return the title of each of the books that the author has authored. So if we run that operation like so, you'll notice that we have our 9 authors, each with the book that they have authored. And if we take a look at the queries that the API has executed, you can see that we've selected ID and name from authors in order to return us the author ID and the author name. And then notice how we've selected ID, author ID and title from books, where the author ID is in our list of 9 author IDs. That's in much the same fashion as what happened with our author data loader when we were querying for the author of a book. But this is essentially just the inverse of that relationship. So instead of doing the one book to one author, we're doing the one author to many books side of the relationship. So what that author books data loader is essentially doing in the context of the resolver is it's going to execute the resolver once for each of the 9 books, and it's going to call down into the data loader, passing in the author ID, So it's going to make that call 9 times. And then the load grouped batch async method is going to execute once after each of those resolvers has had their logic executed. The grouped batch async method runs once, and the list of keys is going to be our list of 9 author IDs. And we're then essentially running this query that you can see in Entity Framework, querying for books where the author ID is one of those 9 author IDs in the list of keys. And it's then converting that into a lookup using the author ID as the key selector within the lookup, and the values within that lookup are the list of books that the author ID has authored. And internally, Hot Chocolate is using that lookup within the grouped data loader internally to convert that author ID to a list of books, the list of books then being returned from the resolver for each of the 9 executions of that resolver. So what I've shown you is how you can go about creating batch data loaders and grouped data loaders. Just to summarize, the batch data loaders are for one-to-one relationships, or when you're doing a lookup of a single entity by an ID. In this case, we're using the one book having one author relationship to use that author data loader to batch the request to get each book's author, so that instead of running 9 queries to get the author for each of the 9 books individually, we are running a single query to fetch all of the authors where the ID matches the author ID of the book. So that will condense down those 9 individual queries into one query, and that's using the batch data loader. And then I've also shown you how you can use the grouped data loader to batch one-to-many operations. In this case, batching the operations where we're fetching the many books that one author has authored. So that's the one-to-many relationship using the grouped data loader. In this case, passing in the author ID as the key and then fetching each of the books that the author ID has authored, reducing the 9 individual queries to get books where author ID equals author ID 9 times into one single query, getting all of the books where the author ID is in the list of the 9 author IDs that we get from the author's request, from the author's table in the database. So data loaders, the batched data loader and the grouped data loader, allow you to make your GraphQL API more performant, and they can significantly reduce the amount of load that's required on a database by significantly reducing the number of queries that the API is executing within the database. And of course, as much as we've just used databases in the purposes of this sample, you can use data loaders with any other source of data, not just databases. For example, if you have another API that you get the data from, and the API has endpoints to be able to pass in multiple IDs, then you can use the exact same logic that we've done with the database inside the data loader implementations, but instead of using database queries in Entity Framework, you'd instead use HTTP requests to your other API data source. So I hope you found this video useful. Thank you very much for watching, and I'll see you next time.